Good morning and once again welcome to my YouTube channel, Maths with Ease by Mr. Kamotho. And in this video I want us to express the explanation of what composite functions are. We understood in the slide that the composite function is when a function is followed by another function, and we have understood that if a function is written, the function of x is x squared and another function of x is x plus 2, those are two different functions, find FG3. We have understood in the previous video or in the slide that when a composite function is written in the form of FG3, we first of all perform the G3 first and then followed by the function of f. The G3 function has its own range. The range of the inner function becomes the domain of the outer function. And this is now the knowledge we are going to use in explaining this example. So our function x is x squared, fx is x squared, and gx is x plus 2. Now find fgx. The inside function first, moving outside. That is, so we start with G3. Our G3 is, our 3 is the raw material. So 3 plus 2 is 5. Now 5 is the product, or it is the range of the first function. That becomes now the domain of the second function. So it follows that now we have f5, whereby the function upon f is x squared. So whatever the value of x is, we square that. So 5 squared, we get 25. So fg3 is 25. What about gf3? Now, instead of starting with g, now we start with f. So we are having f3, and the function of f demands that we square every domain. This means 3 squared, giving us a 9. And now it is the 9 which becomes now the domain or the raw material of g. So g9 is now 9 plus 2, 9 plus 2, which is easily 11. And that is now gf3. You can clearly see fg3 is not equals to gf3 because 25 is not equals to 11, even when we start with the same domain. They are not equals to. In fact, we can just conclude fgx is not equals to gfx. It's not automatic. What about fgx? We start with gx, and gx is simply this, because x is not known. X is not known, so gx is x plus 2, because x itself is not known. It is now the f of the range of this, which is x plus 2, and this is going to be x plus 2 now squared according to f. And x plus 2 squared, you may want to expand that, but even if you left it that way, it is still okay. If you want to expand that, then you will multiply the same bracket twice or by itself twice. Then you'll have x squared plus 4x plus 4. It is all right. What about gfx? We start with fx first, and fx is always x squared, and then it is the x squared which becomes the domain, and as you can see, it is simply x squared plus 2, because the new domain is now x squared, and gx, it's actually x, which is the domain, plus 2, which is x squared plus 2. What about ggx? We have to be careful here, because gx followed by another gx. We first of all perform the gx, which we know easily it is x plus 2, And then this one is now the new raw material or the new domain for another function g, because we have to perform g first, followed by another g. So another g is x plus 2, where x plus 2 is the raw material. And because gx, the function according to gx is x plus 2, and our new raw material is x plus 3, then wherever we come across x, we write x plus 2, of course now plus 2, because this is x and the new x is that. So we have x plus 4, and that is the final submission to that question. So that is it. Composite function explained in one example. Let us meet in the next video. Thank you.